Hi everyone, today's lesson is on algebra and arithmetic equations. And we're also going to look at the acronym GEMS in order to solve algebraic equations compared to arithmetic equations. So your learning goal says compare an algebraic solution to an arithmetic solution, identifying the sequence of the operations used in each approach. So you should have your foldable pasted onto your page. It should be kind of in the middle of your page, and it's pasted all the way down. It's really just used as a diagram. We're going to work off of it, but if you stick it in the middle of the page, you should have plenty of room to do everything else that you need to. So first, I want to define the difference between arithmetic and algebra. When you look at the word arithmetic, there is actually an E, so it looks like it should be arithmetic, but because we're talking about an equation, we're talking about arithmetic equations. So that's why I kind of keep stumbling over that word, but just so that you know, it is an arithmetic equation. And it's a mathematical equation that includes arithmetic. Now, what do I mean by arithmetic? I mean your basic operations, right? So it's going to include addition, subtraction, multiplication, and division for all kinds of numbers, for whole numbers, decimals, and fractions. So arithmetic equations can contain any of the operations that we're used to, in addition to working for numbers that are whole numbers and numbers that are smaller than 1, which is our decimals and our fractions. Algebra equations, on the other hand, are an area of mathematics which has letters expressing numbers. So an algebraic equation is any time you see a variable. Anytime there's a variable in your equation, it's going to be an algebraic one. And again, it also has the addition, subtraction, multiplication, division, whole numbers, decimals, fractions. You'll probably also see some grouping symbols like parentheses or even some exponents. So all those things come into play for algebraic equations. So really the big difference here, algebra has variables, arithmetic does not. So moving on, I want to look at this diagram for you for just a minute. This is the GEMS. A lot of you may have heard of PEMDAS, and we even talked about PEMDAS in our last video. And PEMDAS helps us determine the order of when we perform certain operations. So PEMDAS says parentheses, exponents, multiplication, division, addition, subtraction. Well, PEMDAS is kind of old school, and what's coming into a lot of mathematical vocabulary is this term GEMS. And GEMS, I think, is a little easier to remember, and I think it also clarifies some things that were confusing about PEMDAS. So in GEMS, the first thing that you're going to do is the grouping symbols. So grouping symbols are really, let's start with blue. Anytime you see brackets, braces, or parentheses, anytime you see numbers with an operation grouped together, like a bracket or a brace or a parenthesis, those are called grouping symbols. So anytime you see those kinds of symbols, you're going to do that component of the equation first, right? Grouping symbols always go first. Second, we're going to work on the exponents. So exponents are those little numbers that are kind of up and to the right of a whole number, and they account for how many times you're going to multiply that whole number by itself. So 5 squared, or 5 raised to the 2, has you multiplying 5 by itself twice, 2 times, right? 9 cubed would have you multiplying 9 by itself 3 times, because there's a cubed is the 3. So anytime you see exponents, those are going to be solved immediately after anything that's in your grouping symbols. Now sometimes this is confusing because exponents exist in your grouping symbols. So you don't want to ignore the exponents when they're inside grouping symbols, but you'll get a chance to try a couple and see how that works and what I'm talking about exactly. So next we're going to do multiplication and division, or divide. So it says multiply or divide. And when you multiply or divide, there's a couple of things that you want to keep in mind. When we're looking at algebraic equations, there are different formats to write multiplication and division. For example, A, B is the same as A times B. We've practiced a little bit of that with our coefficients. When we see something like 2x, that's actually 2 times x, right? Same thing if there were parentheses, A, parenthesis B, close parenthesis, that still means multiplication. In addition, we're expanding our definition of division to include fractions. We know that fractions mean division. So if you see something like C over D, that's a division problem. So you want to make sure that you're doing that in this category as well. And whenever you multiply and divide, you're always going to solve your problem from left to right. So all the multiplication division that's existing in your problem, you're going to do from left to right all at once. In any order, right? It could be multiply, divide, divide, multiply, or it could be all division, or it could be all multiplication. Those two things are going to go together. You're just going to do them from left to right. Lastly, your subtraction or addition. Similar to multiplication and division, they are going to go from left to right. And adding and subtracting really are always kind of the symbols that you recognize. So you shouldn't be too worried about having to interpret anything. The only thing I would keep in mind is that if you have something along the lines of a number with a subtraction symbol inside parentheses like this, that usually means it's a negative number. And we want to remember to treat all of our negative numbers just like subtraction. Or, on the other hand, treat all our negative numbers like an addition problem with the negative. So you just want to concern yourself with whether or not it's negative and make sure you're keeping track of those things. So we're going to do 2 examples together before I ask you to do one for your proof problem. The first one says 9 minus the quantity 4 squared times 9 plus 4 cubed divided by 4 cubed. So using my GEMS method, the first thing I'm going to do is the information inside the grouping symbols, which is this piece right here. I have one set of grouping symbols in my problem. They're parentheses, so I need to do everything inside there in the order that GEMS explains. So 4 squared times 9. First I need to do the exponents. 4 squared is 4 times 4, which equals 16. Times 9 is going to be 144. So now I'm bringing down everything else in the equation that I haven't worked with yet. 9 minus 144 plus 4 cubed divided by 4 cubed. So now I've finished my grouping symbols. I don't have any grouping symbols left. And the next step in my GEMS is to do the exponents. So I need to do 4 cubed and 4 cubed. Well, 4 times 4 is 16, and then 16 times 4 is 64. So I'm going to replace those two values in my equation and bring down everything else. 9 minus 144 plus 64 divided by 64. The next step of GEMS is to multiply or divide. I only have one division piece in this problem, so I'm going to do that first. 64 divided by 64 is 1. Bring down the rest of my problem. 9 minus 144 plus 1. The last part of GEMS is to subtract or add, and remember I need to do this from left to right. So first I need to say 9 minus 144, and that's going to be negative 135. Then I do plus 1 is negative 134. So my final answer for that whole long, very lengthy problem is negative 134. This problem had all of the steps of GEMS. Not all examples are going to have that, but just to give you a heads up of how many steps there can be. It's really important to be able to see the difference between solving a step and also moving on and combining like terms. So, for example, when I first solved this problem, I look at the parentheses, then I looked at the exponents, then I looked at the division. Now I'm looking at the subtraction and the addition, and I made sure that all the steps that I followed were in the correct order. The second example we're going to do, again, has that grouping symbol component to it. So the first thing I need to do is my grouping symbols. Inside the grouping symbol, I also follow the order of GEMS. So 2 squared is 2 times 2, which is 4, minus 7. 4 minus 7 is negative 3. So now I bring everything else down. 8 squared minus negative 3 minus 8 divided by 7. Now here's something that's interesting. 4 minus 7 is negative 3. But there's this minus sign after the 8 squared that I have to bring down, right? It's right here. So what I ended up doing was 8 squared minus negative 3. If you remember from our lessons on integers a couple weeks back, when you subtract a negative number, you're actually adding. So 8 squared plus 3 minus 8 divided by 7. That'll help us to keep things straight and not have to worry about double negatives. So the next step in my GEMS method is to do the exponent. So 8 squared is 8 times 8. 8 times 8 is 64 plus 3 minus 8 divided by 7. Now I need to do all the multiplication and division. There's only one division piece back here. It's 8 divided by 7. So I would say 64 plus 3 minus 8 sevenths. I'm not going to worry about actually solving that because I can use the fraction in the equation without an issue, really. So I'm going to keep going. This is the last step, which is my addition subtraction, and I need to do it from left to right. So 64 plus 3 is 67 minus 8 sevenths. I could do two things here. I could think to myself, 8 sevenths is really 67 minus 1 and 1 seventh. So 67 minus 1 would be 66, and 66 minus 1 seventh would be 65 and 6 sevenths, right? There would be 6 sevenths left over when I remove 1 seventh. So I can do it that way, definitely, because in my brain, this makes perfect sense. That is a solution. I can also change 67 to have a common denominator to 7, which would be a lot more work, right? I could say, okay, how do I get a denominator of 7 with the whole number 67? And I would have to multiply that by 7. So I'd have to say 67 by 7 would probably be a very, very large number. And I would put that over 7 and then just subtract 8. I feel like my method was a little more straightforward. I had to do some thinking about it. It's not like this is going to be an exact answer. If you wanted to change the 8 sevenths to a decimal point, you could, and then just subtract from the 67 at this point as well, and you wouldn't have an issue either. For me, I like to work with fractions. Fractions are more accurate than decimals in my perception, and in many instances in mathematics, fractions are much more exact than decimals, so I wouldn't worry about it too much. The last thing you're going to do is to make sure you fill out your left side of the page, and also to complete your proof problem. Please show all of your work.